Sure, no problem.
I'll just put it on the WhatsApp group also for people to join. We have started. I'll just put it. So how many days you will be in India if you're
Probably
coming
a
next
week,
week?
1 week.
Okay. Because our next cohort is December 1 to 6. So will you be
Yeah,
available?
yes, yes, I'll be available.
Okay. Good evening, Dr. Pushpanjali. We're just waiting for couple of more of your colleagues to join in. We have 20 participants right now. Good evening, Surendra Veruji. Radhaji, good evening. So I think we should start and people can keep joining in because I'll also take a couple of minutes for some housekeeping instructions. Welcome to all the respected faculty members who are joining in on day 2 of this AICTE sponsored and NASCOM organized online faculty development program on generative AI fluency. The course is available on the Future Skills Prime platform. I'm going to put the link over here in the chat. The content of the course is over there, and you can go to the. We have created a group for you also, so hopefully you can see the things over there. I'm just putting that in the chat. Your attendance is being tracked on Zoom. Please note your attendance is being tracked on Zoom and will be uploaded in bulk next week. So if you see the Atal portal right now, you will not see your attendance because we have not shared it with AICT yet. So please keep in mind attendance will be uploaded next week. So kindly do not send messages that my attendance is not updated, my attendance is not updated. We will be doing it in bulk. We will be doing it in bulk on next week. We have spoken to AICT. We'll be sharing with them. And attendance is tracked through Zoom. So please use the same Zoom ID which is there on AI Atal portal. And with that, I'll hand it over to Dr. Pramod Dasan, who is joining us from Prague. Dr. Pramod Dasan is Director AI at DHL Group, DHL IT Services, and he works very closely on AI and how to use AI for for making a better customer experience and for providing customers a better experience. So, uh, over to you, Dr. Pramod. Please take this forward.
Yeah, thanks, Kamana. Thanks to all the participants for joining in for generative AI in the field of robotics. Um, so the next 90 minutes, we will be looking at, just a second. Okay. So here is the full agenda for the next 90 minutes. So it is divided into four modules. The first one is the rise of Gen AI in robotics. Um, the second topic will be on generative AI. The third topic will be on integration of Gen AI and robotics. Finally, all the industries where robotics is used using AI. So these are the four modules. Before we start, let's understand why we are spending time to understand AI concepts. As you see, like we had industrial revolution, we had the dot-com boom, and now we call this as an AI boom, right? And always there is a positive, the pros and the cons whenever such a big leap happens in terms of technology standards, right? So there's a famous statement which I want to understand is the future of AI. Why we should learn AI is AI will not replace humans, but the humans using AI will be replaced by the humans who don't. What it means is if I don't know what AI is, if I don't know what DeepSeek or ChatGPT or Perplexity, Comet Browser, how can I use AI to ease out my work? Then I will be replaced by a person who knows it because the jobs can be efficiently done. So that's one of the primary aim of why we should all have a high level understanding of AI. So what we're going to do is the scratch on the surface. Depending upon your areas of interest, you can go deeper. So with that, let's kickstart the module one. Whenever I see the word robo, um, so I look at this small cartoon. If you know this cartoon, it's called the Robo. Used to be a Japanese series which used to be telecasted in Doordarshan when I was a kid. So always the robotics gets fascinated, uh, and I just want to ask a very simple question before we start. Um, do you know where the word robo originated from? From which language or which country? If you know the answer, just type it in the chat window. Just curious to know. I'll just give a minute. So the word robo comes from which language or which country? I mean, don't worry. I mean, I'm happy to correct. Just take a guess. India, China, US. Yeah, the first one is German or slash Germany. Dr. Gurvishal. Okay. Vishwajit. Yeah. So German and Czech close by. Yeah. So actually, Vishwajit is correct. The word robo comes from the word Czech language. It comes from the word Czech language. It means forced labor. A little bit of history here. When Russia invaded Czechoslovakia, when it was part of the USSR, so the Czech Republic used to be the manufacturing hub, and all the people were worked in the factories. constructing powers and cars, etc. So it was a part of the Industrial Revolution where people worked, and then the word robo comes from the word robota, from the Czech word, right? It is used. The meaning of robota means a forced labor. It was first used in one of the a drama by a play by Karel Čapek in 1920. So that's the history of the word robo. With that, let's start off with the introduction. So in this module, we will look at how generative AI algorithms is used to create innovations in the field of robotics. So primarily, there are two aspects of it. One in the robot design and prototyping, how GenAI quickly accelerates the commercialization of robots, reducing the time to market, and how AI is used for simulation and training because it's very, very important for the robots to learn, adapt to the environment so that it can be used in a much safer way, both in the industry sector as well as in the household sector. So that's the whole point of the two modules that we will cover here. To start with, um, the whole robotic market is about 15.2 million in the year 2022. The projection is about 856 million, close about $1 billion by 2032, with an annual compounded rate growth of 34% year on year. Right? Let me slightly adjust. Yeah, there's a highly significant industries, industry robots, as well as there's a huge market in the domestic for household as well. Um, So that's one of the primary reason why this robotic industry is expanding at this point in time. So let's look at a start of the small video how DHL is using robotics in warehouse automation. So this is an automated warehouse where you will have the robotics being used for the pickers and packers. Um, so you can see huge robots are being, for the huge warehouses where the robotics are deployed for pickers and packers. So that's one of the industrial use of robots, which you can see. So let's look at the competitive landscape. What are the key market players in the robotics? Let's split this into a hardware, software, and in terms of hardware, we have Boston Dynamics, which is doing the complete design of robots. NVIDIA, who is the AI chip maker, provides those chips. We have OpenAI, and Siemens also part of OpenAI delivers the overall software. Siemens provides also the hardware integration. So these are all few key players which it's a product breakdown for a robo, which is a key player in the market. So let's look at a small video on Omniverse, how the digital twin factory and NVIDIA, how they participate in terms of the digital twin. So let's watch the short video and then we will go through.
The world's industries are accelerating digitalization with over $3.4 trillion being invested in the next 3 years. We at BMW strive to be leading edge in automotive digitalization. With NVIDIA Omniverse and AI, we set up new factories faster and produce more efficiently than ever. This results in significant savings for us. It all starts with planning, a complex process in which we need to connect many tools, datasets and specialists around the world. Traditionally, we are limited since data is managed separately in a variety of systems and tools. Today, we've changed all that. We are developing custom Omniverse applications to connect our existing tools, know-how and teams all in a unified view. Omniverse is cloud native and cloud agnostic, enabling teams to collaborate across our virtual factories from everywhere. I'm about to join a virtual planning session for Debrecen in Hungary, our new EV factory opening in 2025. Let's jump in.
Milan is joining.
Hello everyone.
Hi Milan, great to see you. We're in the middle of an optimization loop for the body shop. Would you like to see?
Thanks, I'm highly interested. And I'd like to invite a friend.
Sure.
Hey Milan, good to see you.
Jensen, welcome to our virtual planning session.
It's great to be here. What are we looking at?
This is our global planning team who are working on a robot cell in Debrecen's digital twin. Matthias, tell us what's happening.
So we've just learned the production concept requires some changes. We are now reconfiguring the layout to add a new robot into the cell.
Okay, but if we add a new robot on the logistics side, we need to move our storage container.
All right, let's get this new robot in.
That's perfect. But let's double check. Can we run the cell? Excellent.
Milan, this is just incredible. Virtual factory integration is essential for every industry. I'm so proud to see what our teams did together. Congratulations.
We are working globally to optimize locally. After planning, operations is king. And we've already started. To celebrate the launch of our virtual plant, I'd like to invite you to open the first digital factory with me.
I'd be honored. Let's do it.
Okay. So in the first two videos, what we have seen is the interaction of humans and robo. That's the first, the DHL one. The second one where you can see how the physical world is being replicated as part of digital twin, where the entire factory is modeled under the software called Omniverse, which is a cloud native application. In a traditional setup, where if you want to move the robo or if you want to change the layout, there has to be a planner who comes in, understands the layout, has to do the planning, and then if there's any change or any issue, they have to do a rework. But what they've done as part of digital twin, the jargon used here is digital twin, which means that the physical world, the production line of a factory, is replicated into an IT world. And you can literally configure, reconfigure the robotics in the production line. And you can do a what if assessment and you can look at applying the Six Sigma concepts and see whether the production line runs efficiently. So that's the world of the robots, digital twins, and how NVIDIA is accelerating this and how this is used in the BMW as part of the EV factory, which is close to Hungary. So those are the two summary of the videos, right? So as I mentioned earlier, so robots consist of software, hardware, and the services. These are the three segment sectors. On the module 4, we will talk about how robotics and AI is used in the various key sectors. That includes health service, automotive industries, agriculture, and other industries, right? Okay. So we have completed the module 1. We will be entering into module 2, and we will break down what is GenAI means and how GenAI is used in AI revolutionizing the robotic world, and how it enhances the innovative design, and how it helps in the simulation and training. So these are the subsequent modules that we will be covering. Okay. So I'm using GenAI. It's expanded as generative AI. It is nothing but it used to refer to the trained neural networks generating the new content based on the input and hence, right? There are technologies like ChatGPT, DeepSeek, Tail, etc., which is used for capability of languages, image generation, etc. Right. Just give me 1 second. I need to pick this call. Sorry, I'm back. There was some small emergency. Um, so let's understand how GenAI works. There are various models involved in the GPT. So we will understand what a transformer, what a neural network means, and how the tokens are generated, um, and what are the various parameters involved in GenAI in this short video.
Meet Emma, a graphic designer working on a new project. One day, her colleague mentions a tool that helps create designs, images, and text using AI. Intrigued, Emma wonders how AI can create something from scratch. Her curiosity grows, and she decides to dive deeper into this new technology called Generative AI. Generative AI refers to a type of artificial intelligence designed to create new content, such as text, images, music, and videos. Unlike traditional AI, which analyzes or categorizes data, generative AI produces original content based on patterns learned from vast datasets. Essentially, it generates new, unique material. These models are often trained on large amounts of data and use sophisticated algorithms to mimic human creativity. Tools like ChatGPT or DALL-E can create art, write essays, or simulate conversations by generating outputs based on user prompts. Generative AI has a wide range of applications. Content creation. Tools like GPT-4 generate text, blog posts, stories, and essays from simple prompts. Art and design. AI models such as DALL-E generates unique images and designs based on text descriptions, transforming creativity in art. Music and audio. AI can compose music or replicate voices, offering new possibilities for musicians and audio engineers. Healthcare. Generative AI simulates disease progression or creates synthetic medical data, helping doctors gain faster insights for research. Let's take image generation as an example to explain how generative AI works. Data collection and learning. AI models like DALL-E are trained on large datasets of images paired with text descriptions. These datasets teach the model to recognize different objects, colors, styles, and how to associate text with corresponding images. The more data the AI learns from, the better it can generate accurate and diverse images based on user prompts. Neural networks and transformers. When Emma inputs a prompt like a cat wearing sunglasses, the transformer model processes the text, recognizing words like cat and sunglasses, and links them to images it learned from during training. Transformers help the AI decide how to combine these elements into a coherent image. Tokens and context. The text input, such as a cat wearing sunglasses, is split into smaller parts called tokens. The AI processes each token and understands their relationship. For instance, it knows the sunglasses should be placed on the cat, creating a contextually accurate image. Feedback mechanism. Generative AI models improve through feedback. After generating an image, users provide feedback on the accuracy or quality of the output. If Emma's generated image shows the sunglasses floating beside the cat, she can mark it as incorrect. The model uses this feedback to improve future image generations. Reinforcement learning. Reinforcement learning further enhances the AI's ability. The model is rewarded when it generates accurate images and corrected when it makes mistakes. For example, when Emma describes a sunset and the AI produces a vibrant sunset image, it receives positive reinforcement. Over time, this method refines the model's ability to generate better images. Data science and AI models. Data scientists curate the training data and define the parameters that help the AI generate accurate images. The more varied the dataset, the more versatile the AI becomes in generating diverse types of content. Advanced models use billions of parameters, which are settings that guide the AI in processing data and generating outputs. Generating original content. Once trained, the model can generate original images. For example, Emma might describe a futuristic cityscape, and the AI would produce a unique image based on what it learned. The generated image isn't just a copy of past data, but an entirely new creation, showcasing the AI's ability to combine learned patterns and creativity. Now let's have a quick fun quiz on what we have learned so far. What does generative AI primarily do? A. Analyze data. B. Generate new content. C. Store data.
Yeah, and you can type the answer in the chat window. I will send the links for the videos along with the presentation deck. I hope you can hear my video sounds as well, right? Yeah. So please read the question. Primarily do, that's a key word. So we have Vishwajit answering it. We have Ranjita. Yeah. I'll give another 25 seconds. What does generative AI primarily do? Yeah, I'll wait for another few more seconds. Yeah. So the answer is B. So the primary GenAI does is generate new contents, as we have seen. It can generate images, it can generate text, right? And then what we have seen in the video is how it is done through neural networks and the transformers. We know how we design transformers. Like if you put a phrase into your ChatGPT, DeepSeek, or whatever tool that you're using, it breaks down, and then it definitely analyzes data, it stores data, but primary objective of a Gen AI is to generate new content, right? So the answer is B. But if you don't use the word primary, then all the three are correct because it analyzes the data, it stores the data, and generates the content in the order. Thanks for answering. Yeah. So we also saw about tokens, right? So what do you, I mean, just for the jargon here, So when you buy a premium version of ChatGPT or let's say Google AI Studio, you buy tokens for $20 per month, and depending upon your usage, your tokens goes down. So the word token is used by nothing but you buy the subscriptions for the particular AI. So that's the word tokens. You need to understand that. Um, let's look at using since GenAI creates contents and images. There is a lot of risk involved in replacing of jobs, like for example, blog writing, content creation, coding, etc. So I will ask one small question. In US, because of Gen AI, do you know which occupation is heavily impacted? I just wanted one occupation, the top one, which is heavily impacted through Gen AI. I can give you option A is IT in terms of coding, option B, advocate. You can choose the law. So you can choose any one in this two and tell me which one it is. Manufacturing. So I've just yeah, IT. Yeah, which job is impacted because of the use of Gen AI, IT or law in US? Okay. Unfortunately, what happens is the law. I think yeah, Jitendra is correct. Law, because US is looking at the using Gen AI, all the law firms, because the whole law is to understand your previous cases, take the notes, and review of the documentations. So the use of Gen AI will heavily impact the law firm because law is most expensive job in US. Yeah. So thanks for answering. So we saw the jobs. I mean, of course, IT is also impacted, but it also opened up a lot of new venues within IT. So, for example, in the subsequent module, I will talk about agentic AI, which will impact the coders, but it'll also open up a new avenue called prompt engineering. We'll talk in a minute. So let's look at how technology advancement happens. Usage of robots in kitchen. So let's watch this video, how the robot industry transforms the food sector.
As robotics-obsessed engineers, we set out to create a new, efficient way of cooking food. Our woks cook by constantly tumbling your food, which provides a really nice and even sear. They're heated with induction, and we have temperature control to perfectly cook your meal every time.
From our humble starts in our fraternity basement, we developed a prototype that really sort of proved we could build something that can create delicious, high-quality meals.
I needed to come to Boston. I discovered that the robotic kitchen brings precision, consistency, taste, and also freshness to the preparation.
We race for progress.
So I'm not sure how it'll cook Indian food, but that's um, a sneak preview of how robots are taking over the kitchen, where you can enjoy a Michelin star cuisine using robots because the data is repeated, the menus and the instructions are repeated. So how robots are taking over the food industry, right? Now, let's look at we will I'll introduce to one more terminology called generative augmentation or GenAug. So how this GenAug is a promising approach to enhance the robotic capabilities, right? Let's understand through a small video.
In this work, we present GenAug, retargeting behaviors to unseen situations via generative augmentation. Current robot imitation learning systems often require humans to provide demonstrations. While this method may succeed in environments that are similar to the training set, they often fail in environments that are far from training distribution. Our system GenAug closes this gap by automatically generating a large and diverse set of training data using text-to-image generative models.
Yeah. And just to put a context in place, uh, the instruction is to put the mouse box into the basket. Uh, so, so here's a demonstration and how the generative augmentation is used for training of the robotic arm under different context, that it can use the same robots in a workplace, in a kitchen, and in a standard condition. So we will be learning how the generative augmentation is used for training the robotic arm. This is a new way of training the robotic arm, as we saw how GenAI requires a lot of data and regenerative learning is also important. So this is a module how we can generate a lot of scenarios for training the robots. So that's the background or the context.
Given a demonstration on one simple environment, GenAug can automatically change the texture of the objects in the scene, change the object classes, change the table and background appearance, and add distractor objects. So starting from the initial single environments, we can automatically generate a much larger and more diverse dataset. Here we show more visualizations. We use a 6-DoF XMR robot with a vacuum gripper mounted on the large table with an Intel RealSense camera mounted on the tripod. Given a few demonstrations of a behavior in a simple environment and the associated text prompt, our goal is to transfer this behavior to any unknown scenes. To do this, a user generates a small dataset by specifying pick and place locations. These 2D locations are projected to the 3D points in the robot coordinates using calibrated depth maps. We then applied GenAI to create a large and diverse dataset and train a language-guided imitation learning model. Here we show our real-world experiments. By training on the dataset extrapolated from only 10 demonstrations in the simple environment on the left, the robot is able to solve the task in entirely different environments on the right. Here we show another example with a new training object pair. Note that the demonstrations were collected in a relatively simpler scene. The right shows zero-shot transfer to complex scenes with dense clutter. Our system can also generalize to unseen object categories. This implies that agents with behaviors demonstrated with one set of objects can now transfer to other unseen compatible objects. Here we show more real-world results.
Yeah. So here, from a perspective, you can see how the gen augmentation helps to create a lot of data that will help us to train the robotics. Another example is how the self-driving car or the software is learning. So previously, the first school of thought was to mount and or build a car, mount all the sensors, drive the car in all the areas. So it has to go through, let's say, 50,000, 500,000 kilometers across various conditions, and then it will able to train the software. But now with gen augmentation, you can drive at one terrain and you can change the terrain, change objects. You can simulate the environment, generate the data for the self-driving software to behave so that your model can be trained, right? So this is what you call, from a concept perspective, it's called generative augmentation. In the previous video, we have seen how GenAI works. So where we had 7 steps involved, where reinforcement learning happens. So generative augmentation is a technique used to generate data for reinforcement learning. So, and also you need to understand something called hallucination. Sometimes what happens is the generative AI sometimes hallucinate. For example, if you do prompt engineering in ChatGPT, and then if you're talking with respect to a subject, and if you change the subject, it doesn't know what to answer, and then it gives a wrong information. It's called hallucination of AI model. So there was a video where the customer service was trying to talk to a robotic customer agent, and then it went spiral. It's called spiral effect or hallucination, where the customer agent started swearing at the real customer. So it's called customer hallucination. There's a YouTube video So now they're redefining the models in order to remove the hallucination. So if you hear the word called AI hallucination, it's a terminology used to ensure that the models are working as per the required elements and the models are trained with all possible data sets so that the model does not hallucinate. So just to summarize what GenArg means. So generative augmentation used to improve the AI, using the generative AI to improve the robotic training through augmented images, as we've seen. The traditional training methods faces limitations. That's why it takes longer time to bring commercial robots into existence. But through GenArg, we can see robotics being for home purpose being produced recently. So previously, the robots were heavily used for industry applications, right? So the robots are trained through through imitation learning, replication behavior for demonstration purpose. So gen augmentation enhances by creating those diverse images, diverse environment, and provides various scenarios for the training of robots so that it can work in any environment. The image augmentation technique, you can change, as we have seen the video, you can change the object. So instead of carrying a mouse, it can carry a mobile phone, it can carry a ball. Instead of placing it into a basket, you can place it into a bag. And you can deploy this robotic arm not only in the kitchen, in other rooms if this robotic arm is used for cleaning for domestic house help, for example. Right. Um, so, for example, the augmented data sets is close about 1,000 images created for each task. That's the rough of number of images to be created. The performance shows that at 85% of success in unseen environments where the robotic can adapt itself and learn because it's already trained, and about 45 to 52% success in the task of unseen objects and places to pick. So that's how the efficiency has increased through GenArg. Now let's understand the GenArg model from Meta, which is a parent company for Facebook, WhatsApp, and Instagram, how it is used for generative augmentation.
Generative AI is a new breed of artificial intelligence that's designed to learn and create new things on its own. It has the ability to produce art, music, and even writing that can mimic human creativity.
So generative AI refers to a type of AI model that automates the creation of content.
Most of AI in the last couple of decades has been about analyzing existing data that includes predicting likelihood of failures in systems, detecting frauds, recommending items for purchase, or goal image search that return similar image. Generative AI is very different as it allows you to create new content. Generative AI models use complex algorithms and deep learning techniques to analyze and learn from large data sets in order to create new and original content. These models are trained on a vast amount of data and then use that knowledge to create new content that is similar to what they have learned. Generally, the content generated by generative AI is very similar to the data that they have been trained on. To bring variety in training data and regenerate targeting behaviors to unseen situations, generative augmentation is generally used. Generative augmentation is a technique in machine learning that involves generating synthetic or artificial data to augment existing training data. This is done to improve the performance of machine learning model by increasing the size and diversity of the training dataset, which can help further improve the accuracy and robustness of the model. Generative augmentation can be achieved through various methods such as generative adversarial networks, variational autoencoders, and other deep learning models that generate new data based on the pattern characteristics of the existing data. By doing this, the generated data can be used to supplement the existing dataset, providing a wide range of examples for the model to learn from. For example, in image classification, generated augmentation can be used to create new images that are similar to the existing images but with variation in lighting, angle, or background. This can help the model to learn to recognize objects under different conditions, leading to better performance when faced with real-world problems. Robot learning methods and generative augmentation are the two important techniques in the field of robotics and machine learning. While they are separate techniques, they can be used together to create more robust and effective robots. We have already learned about generative augmentation. Let's look at robot learning methods and what they are. Robot learning methods involves teaching robots to learn and adapt to new situations and environments using various types of machine learning techniques such as supervised learning, reinforcement learning, and deep learning. These techniques allow robots to learn from their experience, make decisions, and interact with their environment in a more intelligent and autonomous way. In robotics, generative augmentation can be used to create synthetic data that represents new and unseen situations or environments, which can then be used to train deep learning models. This can help robots to learn to adapt to new and unseen situations and environments, making them more effective and versatile in a wider range of tasks. For example, in robot navigation, generative augmentation can be used to create synthetic data that represents new and diverse environments, such as different layouts, obstacles, and lighting conditions. This can help robot learning methods to learn to navigate in a more robust and generalized way, improving their performance in a real-world situation. For robot learning to generalize, we must be able to leverage sources of data or priors beyond robots' own experience. Recently, Facebook released
Okay, now it goes back to the previous slide we have seen. So here you can see how the robotic dog is used for carrying. It's been trained by Boston Dynamics in a controlled environment, and it's been deployed for the soldiers in the front line to carry heavy objects. That's an example. So, in terms of the future prospects, so the Gen Arc hold promises to the real world applications because it provides a lot of training data that will reduce the time to market for training. Also, there is a continued research that could lead the breakthrough in the robotic capabilities and adaptability. If you see, we are looking at a success rate of around 50% only, right? So both GenAI and GenOg is revolutionizing both in terms of content creation as well as robotic training. The advancement in GenAI highlights the potential for smarter and more adaptable robots. So with that, we will go to the third module. So I would like to type few keywords for the module 2. So in terms of GenAI, can you describe or at least tell me 3 keywords that you've learned how GenAI works? So I just want to understand just for the participants. So for every task, we have to train the robot to do a task. Yes. So there's a question. So for every new task, yes, close about 1,000 images has to be created for each task. So I just want to have 3 keywords for GenAI, step 1, step 2, step 3. Yeah, we talked about neural networks. That's correct. Training data, that's correct. So let's put a phrase, or I want a keyword that will break that phrase and then gives it for the neural network to generate an image. What that keyword? It starts with T, ends with R. What's that keyword? Store data or no? Transformer, it's correct. Yes. I'm not sure is everybody because there is Dr. Gurvishal Singha says that unblock the challenges at cloudflare.com to proceed. I think this is local Is anybody having challenges to view my presentation or watch the video? Can you type it in the chat window, webinar chat? Or is it just an isolated incident for no issues is coming? Okay, thanks. Thanks, Dr. Sinha. Okay. Okay, and then can you type uh, we need a lot of data. So the other question what I wanted to ask is in the Gen org, for example, why is it so important for what is the usage of Gen org? For example, I just want to understand what is it used for? How GenOc is using GenAI? There is one person who mentioned this uh, in the previous chat. So tell me how GenOc is using in GenAI for the model. I want to fill up a keyword for model, create data sets. That's correct, but for what purpose? The GenOc creates data set, but it is used by for what purpose? In the 7 steps of GenAI, there is something called you have a model and you need to do something to the model to get an outcome. So what is it? I'm looking for a keyword. It starts with T, ends with G. Training. Yeah, that's correct. Yeah. Thanks for your participation. Let's look at the module 3, how the integration of GenAI and robotics is working. So in this module, we talk about the integration of GenAI and robotics, how embodied AI agents or humanoids is. We talk about the robo, right? And here I also wanted to distinguish between the humanoid robots and agentic AI, right? So humanoid robots are the physical robotic part which is deployed in industry robots or in a factory or in a production line. An AI agent is nothing but a software uh, thing. So we need to understand what is an robotic process automation, what is an AI agent, and what is embodied AI agents. So these 3 jargons we need to be very, very clear. If you have a set of tasks which can be monotonous and you have a workflow or a process, you can do automation of this task through RPA. It's called robotic process automation. This is nothing to do with artificial intelligence or AI, right? So you have a continuous task. Take an object, put it in the, I mean, like for example, if you want to have a RPA for reading an invoice, processing an invoice, you have a series of steps. You program it in a software called UiPath, for example, and you automate it. Most of the BPO guys are working on this. So it's called RPA, robotic process automation. This is nothing to do with GenAI or humanoids, robots, right? The second jargon people call is agentic AI. The agentic AI is where most people say that I can have a agentic AI programmer who can write code, or I can equip a programmer who can write good quality codes using GitHub Copilot. I can have a agent for tester who can coordinate with an agent for developer to develop a software. So this is something different than an RPA, agentic AI, and then here we talk about embodied AI agents, which is nothing but a physical robo made up of hardware, software, and other integrated for an application. So just to get those jargons correct. The embodied agents are nothing but the humanoid robots capable of performing wide range of tasks. It can be in industry, it can be in a household, right? It combines hardware and software for intelligent interaction and mobilities. For example, there are robots being deployed in Singapore for police patrolling. There are robots being deployed in United Arab Emirates for helping passengers in Dubai airport, right? These are a few examples, right? And what are the challenges in robotics when we have? There is something called Moravec's paradox, which means that the current robots, when compared to humans, it is not sophisticated in terms of sensory motor skills and which are harder than abstract reasoning. So this is the current challenges in robots we face. Also, the computational resources, right? For AI data center, you need a lot of data and you need a lot of power for computation. So this makes the two challenges in the robotic field, especially in embodied AI agents, right? So what is Meta has done is Meta has done something called artificial visual cortex that is able to mimic the human visual processing, right? So again, like GenAI, you have various models being defined by various companies to fast track the deployment of robots, right? An example of that is called Ego 4D dataset, which has close about of 3,670 hours for human performing task. And for each task, you need 1,000 images. So just multiply and see how many images, what kind of data set is required for performing a task, how much effort is required for training. You can do a calculation. Right, and also this data set is used to train robots, like we have seen in the video, the Boston Dynamics, the manual, the robotic dog, which is used to climb staircase, a hurdle, which is deployed in the front line for army as well for practical applications. Right. So robots could perform household tasks, like for example, you have robotic cleaning, the vacuuming and mopping, for example, which is available at home. And we also need to look at the data. For example, Amazon has bought this robotic vacuum cleaner. So once you have the data, for example, if I have the data vacuum robo, I can assess your data of your apartment or a house. I can use this data for combining with the other data sets, let's say with Alexa or Google Assistant. I can combine this data. I can find out that, okay, what kind of uh, possible household items I can sell through Amazon, for example. So these are all some of the applications where data science, machine learning are used to develop this. So these are some of the practical applications how data is used. We'll also talk about the data breaches or the data security in the subsequent topics as part of the responsible AI. I will cover it in a very high level, right? So concerning about data privacy, for example, especially Facebook, uh, often, which is one of the pioneer, that it will develop a software and it needs lot of data to train its model. And what it uses is it will ask the Facebook user, for example, there was one thing that if you upload a photo, it can give you how you look when you're old. So in order for model training, it collects the data from your inboxes, or you can upload all the Facebook albums, and it is used for training the model, for example. And also, the Google has released the smart features in your Google. So you can go to settings, and by default, if you it always updates the terms and conditions. So you have to be very careful in allowing those terms and conditions because Google, when you use Gmail, automatically it reads your data, it reads all your inboxes, it reads all your files in your Google Drive. So data privacy is very important. In Europe, let's understand a little bit concept of data privacy. In Europe, we have GDPR, which is the Data Protection Act, and there's also called EU AI Act available. So whenever I have to deploy robotics or AI system within Europe, I need to get a clearance that this will not have a negative impact for the EU citizens. So similarly, in India, there is something called Data Protection Act called DPDP, which is being enforced, but I'm not sure how strict it is. But your data, your first name, last name, your date of birth, your Aadhaar number, your PAN number, this data is easily available for other people, Just Dial or other companies or Truecaller, when you give access to your phone, all your data is taken and they use it for various marketing purposes. So next time you have to be very careful when you share your data, how it is used and for what purpose is used. That's very important. Potential risk: AI-enabled robots could be collecting sensitive information about the users unknowingly. That's one of the primary reasons why Chinese apps are being banned in India as well. It can collect data for your personal habits, health information, daily activities as well. So in terms of business model consideration, since India is one of the number one populous country, you have vast amount of data, which will be helpful for training for AI companies. So you have to be very careful whenever there's an updated terms and condition comes in. Make sure you read it, understand it, and then activate if you want to share your data or not. So that's on the concerns of the data privacy. So let's look at the video of Boston Dynamics, and let's look at this on the humanoids part, how it is used in a
Boston
production
Dynamics
line.
just dropped new videos of its 100% electric Atlas robot. This is the first time the company has shared videos of this version of Atlas doing something like work, and the first time the company has shown it correcting a mistake. We're digging into the details, so let's get into it. When turning around, Atlas's torso and legs turn in different directions. Given the fully autonomous label on this demo, it could be reasonable to assume the robot made the decision to move that way. Whether it did it because it saves time or energy, I can't say. Pop-ups in the video give us a sense of the robot's vision system and how it marks the different bins it's reaching into. About halfway through this demo, one of the engine covers, that's the item Atlas is moving around, appears to snag, causing the robot to react, reposition, and correct its mistake autonomously. We've seen similar demos from other robotics companies. Figure showed its Figure 2 robot picking up and placing auto parts, even appearing to correct some of its mistakes. Tesla's Optimus robot was also recently shown doing various work tasks, first at the company's We Robot event. However, after reports came out that indicated the robots were human-assisted at the event, Tesla dropped a video showing Optimus in a lab setting doing many similar tasks labeled as autonomous. Another video posted by Boston Dynamics on Halloween shows Atlas doing the same task it did in the previous video while wearing a hot dog costume. In this example, someone dressed as a pickle moves the bins, Atlas catches another snag, and is able to react, reposition, and finish the task. This is the first time Boston Dynamics has shown its new electric Atlas in a work setting. The announcement video shows Atlas rising up off the ground and moving around, demonstrating the robot's hypermobility. At the time, Boston Dynamics said it was developing new grippers, or hands, for Atlas. Later, the company appeared to make good on that promise in a YouTube short. In this video, Atlas did some push-ups with what appeared to be grippers styled like fingerless nubs. Now we're seeing Atlas for the first time with finger-like appendages. Based on the movement shown in these new videos, it looks like Boston Dynamics has applied the same principles of hypermobility to them as they have to the rest of the robot. You can see the finger starts on the bottom to help lift the engine cover, then swivels up to pinch and hold the auto part as the robot carries it to its destination. These new videos of Atlas strutting its autonomous stuff come just weeks after Boston Dynamics and Toyota Research Institute, TRI, announced a partnership to develop AI and robotics. TRI has been working toward the development of a large behavior model, similar to a large language model that generates human-like behaviors instead of text. Boston Dynamics will supply the hardware, and TRI will be supplying the AI. TRI has also been hard at work in the field of self-driving and self-drifting cars. Tesla, one of Boston Dynamics' competitors in the humanoid robotic space, has touted the self-driving features of its cars as a helpful foundation for building out the type of AI needed to power humanoid robots. As Boston Dynamics works toward the commercialization of its humanoid robot technology, it's interesting to see the company partnering with an automotive AI company. Things are really heating up in the humanoid robotics world. Subscribe to CNET for the latest updates. What do you think of humanoid robots? Let us know down in the comments. As always, thanks so much for watching.
Yeah, that's about the humanoids robots, for example, from Boston Dynamics. Now let's look at the last module. What are the various groundbreaking applications where robots are involved, and how Gen AI and Gen augmentation are helping to improve the time to market? So I think in the first module we have seen how big is the robotic industry, 35% year-on-year growth, close to $856 million by 2032. So that's the growth of it. And some of the key use cases in the robotics, this is just illustrative only. So for example, it is used in agriculture, manufacturing, healthcare, transportation, smart home applications, aerospace. Let's look at how it is used. For example, AI in agriculture, robots can enhance the efficiency and crop yields. For example, you can use drone robots for weeding or for pesticides deployment. And robots are used for robotic picking, crop harvesting. You may find it, okay, why are we using expensive robots, for example? If you see in India, we are rich in human capital, at least in Asia. While here in Europe or in Japan, for example, the aging factor is one of the key criteria. There are countries with negative population. So where people are unable to find labor within the European Union, and there are a lot of immigration policies are there. So people are turning towards the robots for harvesting. Using AI and robots, for example, here. Robots picking, for example, that we have seen, robots can identify the fruits using a computer vision. It can pick up the right fruit at the right time as well. So this is used in agriculture field as well. Also, for example, wheat, using the NLP, or sorry, the computer vision, for example, it is able to distinguish between a healthy crop and a weed, and it is using the laser technology to de-weed um, in the agriculture field, right? The second application is manufacturing. So we have seen how the humanoids from Boston Dynamics are used in the production line in manufacturing area, especially if you have time, watch dark factories in China. Or what it means is the entire production line in a factory is operated by robots with zero lights on, which means that right from end to end, zero touch dark factories is the next industrial revolution happening in China. By applying robots, it can run 24 cross 7 production line manufacturing with high quality products in. So that's how the intelligent robots is able to manufacture products. And these robots are used to assess real times for dynamic action. Using Gen AI, Gen augmentation, it trains it and it increases the efficiency. The robots also helps us to inspect machineries for damage, and it helps to increase the productivity of the factories or the production line. Also in the area, for example, in nuclear reactor, where if you have a very, very restrictive environment or a harmful environment where human repairs cannot be taken care, robotics can be deployed, for example, to fix anything in the control rods in a nuclear factory. Also, robots is used in aerospace. For example, if you want, there is NASA Perseverance rover, for example, which explores the Martian soil. It uses AI for object detection, and Airbus Simon 2 Assistant, which is used for deployment of various tasks. So you don't need to do a spacewalk and have the astronauts exposed with the radiations. You have robotic arms deployed to fix anything on international space stations, etc. So we talked about nuclear waste management. We talked about healthcare. For example, in healthcare sector, we have robotic surgeries being performed remotely by the doctors through 5G network. AI is also used in transportation. We have seen robotics, Tesla, self-driving cars, the Waymo, for example, taxis. Uber is also partnering with NVIDIA for development of chips for self-driving cars as well. The other application is smart homes. AI robots is used for household purposes. Example, Amazon Astrobot acts as a virtual assistant and as well as for security monitoring. So these are all few applications or use cases within robotics. As I mentioned, we also need to understand responsible AI, which means that you need to use AI, robotics, humanoids with respect to fairness and bias. You should be able to explain transparency as well and ethical governance. It's more, for example, in Europe, it's very, very sensitive topic on responsible AI. While we take things for granted, so that's one of the reasons why when we compare GDPR against DPP in India, it's still in a cooking state. It is not fully enforced by the government. So in conclusion, when we use AI, you need to harness it responsibly, and you need to foster collaboration. It opens up lot and lot of new opportunities. So you can always debate AI, Gen AI, robotics. We will lose jobs. For example, that's on the consequence side, but it opens up lot and lot of new avenues in the area, in the sector. With that, I conclude the session. Now I'll open it for questions. So we have a few minutes. I can answer your questions. You can ask it in the Q&A or the chat window. Yeah. Cloudflare is nothing but it's okay. It's a security cyber defense software. If that is down, it has brought down everything. It's nothing to do with the AI. So it's just like a gateway to the AI websites, right? So last time when Microsoft Azure was down, like identity management, Azure Active Directory was down, it impacted a lot of entire Heathrow Airport was down. People were unable to fly in and fly out. The entire baggage system was out. So, so this is something like Cloudflare is nothing to do with AI, but it's a gateway for filtering it out. Yeah. And our focus is more on the AI here, Gen AI and robotics. This is a cloud outage. Yeah. So just to talk about the aspects. So, so we have Gen AI, which is the ChatGPT. It is hosted in cloud, and you have AI data center. So these are all the various aspects. Like for a robo, we have a hardware, software, and integrators. So similarly, for here, Cloudflare is a gateway for cyber defense. Okay, thanks, Sina, for clarifying. So any questions with respect to the robotics, Gen AI, GenAg, how it is used? I will look at the Q&A section as well. if there are any questions there. Okay, if there are no questions, then thanks for your attention. Thanks for interaction. So I think the next module will start shortly. Kamana, are you there? Let me see. Can AI make robots overcome the laws? I need to understand the law of robotics detail from Prakash. So let me answer it shortly after going through the law of robotics. In software point of view, how GenAI integrated to the existing robotic software. So we talked about the GenOrg and the GenAI. So Meta has a separate wing for AI. In fact, so the Ego 4D dataset, where you have integration of dataset for training the robotics through GenAI. That's a classical example. So if you look at every big industry, if you look at Elon Musk, he has X, which has your old Twitter. I mean, Twitter, for example. He also has neural networks, which is a chip-based company. So he's using the data to train the neural networks, the Neuralink, for example. So they are integrated. So data is the next oil, they call. Um, uh, uh, I can talk in the DHL warehouse design. For example, pickers, in the first video, you saw a robotics walking across next to the picker and a packer to collect it. In order to walk across a warehouse, you need to have a warehouse plan. You need to know the obstructions. So you have GenArg, which uses the images for training the robotics, and you deploy this robotics in a warehouse. That's an example. Vishwajit. Okay. In terms of model training through generative AI, it is one of the concept to train. Yes, there are other ways of training as well. So if you look at old system where you generate the data, you give it to the model and you train. But Gen Argument is an enhanced way of training, so the time to market will reduce. Any other questions? Okay, I'll just if not, I'll give you the 7 minutes back. I think you will continue the session with the next trainer. Hello.
Yes, yes. The next trainer is yet to join. There are no questions from the
There
faculty.
were a few questions which is answered.
Okay, okay. Just give me a moment. I will. So, how was the session? I'm asking you, Dr. Pramod, how was your session? How was your
Oh, it was good. I think there were a lot of interactions. Um, yeah. So unfortunately, I had one call. Other than that, everything was good.
Okay, okay, no worries, that's fine. I think we had full attendance also. Almost 100 people on the call. And we hope to have you back also. So, yeah, Dr. Gurvishal is saying great session. Basically, I'll just repeat couple of instructions. If you want to log out, you can log out. Dr. Pramod, if you want to do that, I'll just wait
Thank
for
you.
the next trainer to come. Yeah, Dr. Lakshmi Pandey is saying that it's entire upskilling. Great,
Yeah, I
great.
think we just touched the scratch of the surface. We have not gone in detail. So again, depending upon which background or which faculty which you are learning, you have to go deep. It's just a scratch. It's just an introduction session. What I've done.
Right, right. No, no, I agree with you because I think the more you learn, the more you think there's so much more to actually get a hold of or grab. So I think whatever you learn, it's good for your learning journey. And I'll
At
just
least at least from a perspective, I think in Czech Republic they cancelled all the thesis and the assignment for bachelors because a lot of people are using the GenAI to write the thesis. So for
so
bachelor degree, they said no thesis because people use the generative AI to write the contents of the thesis. So it's quite difficult to distinguish whether because you are supposed to write thesis for the bachelor's degree and it should be like 75 pages. So they just go online and they do prompting and you generate thesis in like 30 minutes and you go through the review. So now from a faculty perspective, they said, okay, for bachelors, they will reduce this work. So they're trying to come up with a new technology where they do not want to copy the objects. They want the students to actually do the work.
but my question is that thesis is required even for a postgraduate degree, even for a doctorate. So the same thing the postgraduate students as well as
Can
the
yeah.
fellows can do.
Yes, they can do, but the problem is, at least in Europe, the masters and the PhDs, you have to do a lot of research work. There is a lot of interaction with the supervisor. In bachelors, the number of people who are doing bachelors is so huge.
Hmm.
So when compared to India, it's peanuts. But here, so they wanted to eliminate this because people use this technology. They don't take notes, etc. They use Copilot, auto dictate. They listen. They use Perplexity, or I mean, not Perplexity, the ChatGPT voice version.
Hmm. Yeah.
So they do testing by oral. So yeah. So from a thesis perspective, for bachelors they just cancelled it, but for masters and this one for content generation assignments, people Yeah, they do create this papers, research papers for the bachelors. It's like, yeah, you have to be very mindful when you give assignments. That every kid will write the assignments and submit in ChatGPT.
But that's even I mean, not just the bachelor degree students, even the school students are using the various DeepSeeks, ChatGPT, and Perplexity, Grok to modify their answers. So that is happening even at the school level.
Yeah, actually, my son was using a mobile phone scan for solving his math problem. It gives you step by step for homework assignments. So yeah, I think the next tutor has joined. Thanks a lot.
Yes, yes.
Uh,
Thank you, Dr. Pramod.
yeah,
And thank you so much for that session. And I can see from the feedback in the comment section that, everyone benefited greatly from this. And thank you so much
thank
for
you.
joining us.
Yeah, see you. Bye.
Thank you. I'm very happy to welcome our next trainer, industry expert, Akbar Mohammed from Fractal. Welcome, Akbar. Thank you so much for taking out time to upskill our faculty members who have joined from all over India. We will be sharing the presentations with you in the WhatsApp group, so don't worry about that. Please focus on the lecture. And I just want to repeat once again that all your attendance will be uploaded next week, because we will together take, after 6 days are over, we will take all the attendance, combine it, and then send it to AICT for their uploading. So it will be done by middle of next week, most probably. So please don't worry about that, and please focus on the lecture. Thank you so much. And now it's my pleasure to welcome Akbar, who joins us. He's head of AI at Fractal AI, and his passion is solving complex real world problems using technologies like AI. And he's done a number of projects, in the same direction. So without wasting any further time, let me hand it over to Akbar for his session.
Thanks, Kamna. Thanks for that introduction. I'm excited to be here, folks. For today's session, we'll focus mostly on healthcare and pharma. And I want to give you a practitioner's perspective, like from somebody who's been building these solutions, how this has evolved over the years. That's what I have for today's session. Let me quickly share my screen. Yeah. All right. And zoom in. Yeah. So what I want to do is basically take you through what's happened in healthcare, and then zoom in on different areas. Healthcare is very big, and I'm going to focus on a few places where AI is impacting immediately, and then also talk about what's working, what's not working, and what it looks like in the future. That's what's going to be for today's session. Okay, before I begin, as with anything AI, right, it has to start with data, right? And I want you guys to think about the interactions you have whenever you visit a doctor or a hospital or any clinic for that matter, right? Imagine the number of interactions that happen. As you walk in, you're likely talking to a receptionist. The receptionist might ask you to fill up a form. They might collect some personal information. And then once you move into the clinical zone, you may have interactions with clinical experts. They will take some data. So there's a lot of interactions that happen within healthcare, right? And all of these interactions, it could be handwritten notes, it could be text, it could be media, it could be very complex data like a MRI scan or X-ray. So there's a lot of data in healthcare, and it tends to be unstructured, a lot of it. And that poses a unique challenge, especially for AI systems. Most AI systems tend to, at least in the past, used to work with structured data. When I say structured data, it means there is some number associated with it, right? You can neatly fit that data in a spreadsheet and you can analyze it. But a lot of healthcare data tends to be more complex, right? In the past, it used to be a challenge, but now that we have more techniques, more compute, it's becoming increasingly useful to have this unstructured data for analysis. The first thing I want to maybe start off with is to show you the complex nature of healthcare itself, right? If you are from a patient perspective, these are the number of interactions you're probably having, right? Doctors and nurses, pharmacies, labs and imaging. There might be also financial elements, right? There are bills you're paying on a regular basis for different intervention plans. You're also paying insurance. It could be for a health insurer. It could be even to your employer, right, for your health insurance. And there are other digital health tools that you're probably subscribed to. It could be like a fitness app. There are many healthcare related elements that you are already interacting with. And each of these elements have different kinds of data that is being captured. So it's not just the nature of data that is different. It's also the variation of data that is here that's also very wide. And in my experience, I think healthcare has the richest amount of data, which is highly untapped. And there's actually data backing that also, right? And this data can be used by many entities, right? From people who are giving you care to people who is supporting you for that care. There are industry players, and each of that brings some data challenge, right? And the reality today, why is this? Yeah. Okay, so the reality today is that 80% of this data, this unstructured data, right? Notes written by your nurse, notes written by your doctor, all of that is idle. It's not being analyzed. There's also other more complex data like medical images that is only available to you and the clinical specialist. It's not available for any systems, at least not until very recently. That is changing. So this 80% unstructured data that we are generating is now slowly getting exposed to AI models for not just analysis, but also to create newer solutions. Okay, so that's what we see in the healthcare world. And the other interesting thing is year on year, the data only grows. I mean, it's not growing as fast as e-commerce, but the richness and volume of data is still big enough, and it is growing by 36% year on year. And this kind of gives us an opportunity to do a lot of interesting things with GenAI, and that could potentially impact this $4.3 trillion industry. So there are this is the estimate of costs involved in healthcare, and there's a huge potential for AI to focus on different areas to solve problems. That's what I'm going to focus on in today's session. How is AI being used to solve these problems? Some of those examples could be, doctor burnout, reducing errors in medical processes, reducing inefficiencies in administrative costs. So those are some of those examples. I'll go deeper once we head to that section. So that's the healthcare data ecosystem. And it's a goldmine. Really, the amount of data we have, the kind of analysis solutions that you can create, you can be very narrow. You can focus on specific solutions for a specific condition. Let's say if you want to create a solution for diabetes, you can create just solutions for diabetes, focus on that data and create a range of solutions on that specific clinical issue itself, right? And you can even tackle more broader macro problems, right? How do you think about population health? How do you think about planning, policy making, not just at a country level, but also at a district level, city level? All that is possible because of the amount of data that is sitting there unused, and it is now getting more accessible to analysis and compute. Right? These are some interesting tidbits that I've collected. If you look at the volume today, it's about 2.5 quintillion bytes. That's as big as financial data, by the way. If you are comparing how big is healthcare data, it's as big as financial data. Financial data tends to be moving fast, but the variability, you're only looking at receipts, right? How much did I pay? How much did I receive? But in healthcare, you're looking at a range of items: finance, clinical data, imaging data, audio, visual. There's a huge mix of things. So it's 2.5 quintillion bytes, and it's growing. Today we are only using about 20, 25. We are slowly trying to creep into that unstructured space. How do you digitize that space and start using it for more synthesis, more analysis? That's happening today because of advances not just in the AI side, but also in the compute and data infrastructure side. More and more things are being digitized, and it's becoming more accessible. So the usable data is also increasing, and that leads to a huge economic opportunity, right? It's about $1 trillion of, I mean, McKinsey has a report saying there's $1 trillion of improvement that can be unlocked if you can tap into that 80% unused data. There are several countries, including India, who have potentially billions of people whose healthcare depends on good policy and decision making, not just at a individual clinical level, but also at a macro level, right? So there's a unique advantage even for India to tap into this data. And we know in the immediate short term, you can potentially save. I think this is focused on the US medical sector. There are $200 billion worth of annual savings that we are already saving because of some of these AI solutions. I'll touch upon these. This is the impact, or this is the potential of healthcare data that we have today, and GenAI is trying to exploit it, and we're in like this unique situation where we have not just the techniques, we also have the data, we also have the infrastructure to now tackle this more holistically. That's the unique space that we are in specifically for healthcare. And some of these things were not possible even 2-3 years ago. It's becoming more and more feasible because of some of the advances that we see today. Okay. Now I'll shift gears. Now that I've spoken about data a little bit, I'll talk about the first zone in healthcare, which is patient care. What are some of those applications that we are seeing? Earlier, I talked about structured data, right? Most traditional analytics or even traditional machine learning applications, they require your data to be extremely clean, extremely structured. That limited the range of solutions we could create. Now, with GenAI or deep learning approaches, we can work with this messy data, and most real world data is actually messy. I mean, if you must have seen some of the doctors, how they write handwritten notes, right? It's very difficult for even humans to interpret them. There are also specific diseases, specific conditions that require early detection, right? And with our limited senses, right, our eyes, how we can touch, it's very difficult for humans to do that consistently well. Whereas machines can see this even like at a pixel level, a nanosecond deviation between pixels or video images. All these things can be observed very closely by machines very well and very consistently. That's something that we are unlocking in patient care. The first two ones that I want to talk about is medical imaging and personalized medicine. Medical imaging was among the first few solutions that started being explored for potential solutions, and radiology was among the first. Today, radiologists would look at a scan, and based on their training and years of studying different diseases or different conditions, they're able to detect potential issues, right? But what we notice is the consistency is not very high among radiologists. And one of the things that we started exploring, and this was maybe 10 years ago, right? When early image detection models were starting to come out, radiology was one of the places where we started to explore if machines can do what radiologists can do. Today, we have many startups, many companies that have extremely high quality solutions that can pretty much do what a radiologist would do. They could look at MRI scans or X-rays essentially to identify early signs of tuberculosis or cancer or various conditions that you might look for when looking at a X-ray report, right? So that's been happening. I think we started in 2013, 2014. It was not great at that point. We didn't have a lot of data also, and over the years, slowly more and more imaging or X-ray data was getting available for machines to analyze, and the models would learn from those available images, and they would slowly improve. We've also field tested. There are companies that have also field tested these solutions, and they were quite effective during COVID. There were many companies, including a company called Cure. It's an India-based company. They had been working on radiology specifically. They started off with radiology, and they had tuned their models on, I think, more than 10,000 radiology images, like labeled radiology images. And they worked with the radiologists to figure out if the machine was doing okay or not. Today, they have extremely effective solutions. It was deployed during COVID. We are taking that same AI to remote places. What you could potentially do is, if you don't have access to good healthcare facilities, you could, like a remote doctor can scan an image, take a picture, and send it to an AI, and the AI will diagnose it and give you an immediate. I won't call it diagnosis, but at least things that it is observing. I see XYZ problem, or this is healthy, this is what you would expect. That's possible because of the tech today. Okay. The second two things is a little more interesting, which is in synthetic data generation. Earlier, I touched upon the concept that data was only available to you and the clinical practitioner, right? Like your doctor or the radiologist. And that is by design. And most reasonable countries have data protection, right? You can't share your data, your healthcare data specifically, with other people, especially for commercial purposes. That restriction also meant that it limits the amount of solutions you could build analytically. When I say analytically, it also includes AI-based solutions. That is now not necessarily a limitation. So what is happening now is we are training models to create synthetic copies of X-rays, MRIs, even audio, right? You could create almost realistic features and dynamics that you would see in the real world using models that have been trained on real data. And then what you could do is you could create this synthetic patient population and share that data with multiple entities, because it's not real, right? It's not a real person's data. And based on top of that, you could build solutions. You could build algorithms, other AI models. And today, most solutions are a mix of real data and synthetic data. And that's been happening. And there are many places where you are seeing that. NVIDIA has done this for radiology, for 2D medical image generation. King's College has done this for synthetic brain scans. And there are many others like this. Slowly, we are exploring different parts of our anatomy, disease conditions. We are creating samples, synthetic samples, to hopefully be able to not just create synthetic copies, but also to simulate. The cool thing about synthetic data is you can not just create a copy of a synthetic image. You can also create many of these and almost simulate what could potentially happen. That way, you can also identify rare diseases that wouldn't have been possible with simple data synthesis. So that's medical imaging and synthetic data generation. A key technique there is generative adversarial networks. Maybe I can show you a real example, right? I don't know if others have touched upon this. A really interesting application of this is it's it doesn't have any direct utility, but it kind of shows you the potential of what AI can do, right? I don't know if people have seen this. This person does not exist. Okay, I don't think I can access it. Or maybe this cat does not exist, right? Okay. Okay. Yeah, I mean, I think the person or image is not, generator is not working. I'm going to use this as an example, right? One of the early toy solutions was to create, train models with real data and see if it can generate synthetic copies of it. Now, if you look at these images, right, none of these cats exist. They're all synthetically generated. Imagine the same thing with medical imaging or even X-rays, right? They're able to capture features extremely well. Like, I mean, if you're a human, it's very hard to tell whether this is real or not, right? That's the level of details that synthetic data can generate. You can also increase. I can generate millions of them, right? If I refresh, almost every image gets refreshed, right? You can literally create millions of copies of synthetic data and then use that to train other models, and that those models will capture different features that you're trying to study, or it can even like identify anomalies that may not have been detected if you were just looking at real data. That's the power of AI today. You can use synthetic data to solve for these problems, and the key technique here is generative adversarial networks. There are different flavors of this. I think this one is made using StyleGAN, but it's just a small variation of generative adversarial networks. Yeah. I'll pause here and see if there are any questions before I head into personalization. Okay, I see something in chat. Primary data skills inventory. Okay, I'm not familiar with molecular design. Data scarcity, look, again, it's about being able to, if somebody has been studying it, or like especially rare disease, right? If somebody has been studying it, only then you're able to have some real data captured. If that doesn't exist, it's very difficult to even do anything scientific, right? So that's the first challenge, right? If something has been studied and it's been recorded, then you can actually potentially borrow it for further analysis. The second challenge is sometimes that data may not be shareable. There might be restrictions in how that data can be shared, not just between patient doctors, but also across organizations. One hospital studying a particular rare disease will be limited because they want to protect that knowledge for IP reasons or various comparative reasons, right? So that's another challenge. The third challenge is institutional or government level restrictions. Like a country may be willing to analyze it or have the technology to study it, but some governments will not be ready to share that data. So there are multiple levels of challenges in just acquiring the data. And a key thing that we are able to unlock with synthetic data is that instead of sharing the actual real samples, we are able to create copies of that. We are able to train that model on that data and share the copy of that data. I know somebody asked me what is synthetic data, right? Let me just quickly read that question. Oh, this is not it. Synthetic image. Okay. Okay. I hope you can see this cat image set, right? The way this is possible, like if I hit refresh, there's an AI model that kind of creates a bunch of synthetic examples of cats, right? The way this is possible is that somebody collected thousands of records of cat images. They trained an AI, specifically this GAN model, right? Generative Adversarial Network, to first identify a cat, identify the features of a cat, and then try to create copies of it. And the way it works is, I'll have to give you some knowledge of how that works. Let me open up a, no, I think I'm being limited. Let's see, what can I use? Maybe I'll use Excel, right? So there are actually, within generative adversarial networks, there are two competing models. Okay, one model, let's say, we have a couple of things here. There is real data. Okay, and then there's one model that is trying to fake it till it passes. And there's another model that is actually learning patterns from the real data. Okay, this one is reading real data. This one is also reading real data, but both of them are trying to create some synthetic samples. And their goals are different. Okay. Eventually, there's some evaluator. Right? This one will send features to the, like, let's say first data goes in, both of them learn from that data, and they create some image. This will create some image 1, image 2, and the evaluator, it knows that this data probably has a black cat. Let's say the first one is a black cat. The first model will try to create a black cat image. Second will also try to create a black cat image, and it'll pass through. Usually the image 1 will come out as good, right? Image 1. And over time, what happens is the evaluator will tell, hey, this model that, hey, you're not been good, you should improve. That feedback will go to this model. And then when the next image comes in, it'll tune its parameters and it'll create another image set. And the evaluator will again give it some feedback. And this will happen a million times, right? A million times or more. And eventually, this model that is trying to fake it will create an image that is as good as what the real image looks like, or has the features of the real image. And that usually will end up coming as image 2, right? Once that happens, then you can pull out this model. Okay, whatever this model has learned on, you can pull that out, and then you can create as many images as you like, right? That is what is happening here. They have pulled out that model that is creating fake images, and they're creating synthetic copies of it. And this specific technique, right, where you have two competing models trying to learn from actual data and one trying to fake it, is called generative adversarial network. Adversarial because they're competing. And there's an evaluator that is trying to decide whether the adversarial network has learned anything meaningful or not. Okay, hopefully that made sense. If it didn't, feel free to ask more questions. Okay. Okay, in the interest of time, I will move to the next one, which is personalization. So in patient care, the second one that we are seeing great benefit is in personalized medicine. In medicine, usually everything is averages, right? What works for the general population should effectively is what gets released out there, right? But humans are very unique, right? Like our physiology, the way our dynamics are internally, they are complex. It's very hard to model everybody, right? Now with GenAI, you could essentially create treatment plans based on not just your genetics, but also your lifestyle factors. So somebody, let's say, who is in a particular age bracket, who has a certain genetic makeup, may get a very different treatment, whereas the same person in that same age bracket but has a different lifestyle, right? That wasn't feasible earlier because it's very hard to do that with traditional analysis, right? Traditional healthcare analysis. Now we are seeing AI able to find those patterns at an individual level. Instead of doing one size fits all treatment, we are doing personalized treatments, like depending on what you are, who you are, what treatment plan you're going through, and you can pass that like a lot of details about you to an AI model, and then come up with a specific treatment plan. Mayo Clinic, with a company called Cerebras, has been doing this for, I think, several years now. They have already collected 100,000 patients, and they're giving them personalized treatments. And most of these patients have very unique treatment plans. Either it's not always chronic or extreme. It's a range of things, right? They could be going through some kind of a chronic treatment, but they are very sensitive to what is available in the market, and they're trying to figure what's the best way to treat this person. There are complexities involved, like allergies, or maybe a combination of diseases that they're trying to manage. So for those people, how do you find a treatment that works for them specifically? Like that's what Mayo Clinic and Cerebras has been trying to figure out. And they use genomic data and then like lifestyle and other factors to figure out that treatment plan. There is a lot of encouraging results from this exercise. And this may be the future of how we get treated. But again, it still has to go through all the legal and policy hurdles. But it is possible because of some of the advances in AI today. Okay. There are other solutions, there are protein level LLMs. There are models that are being trained on specific ways of studying proteins that work for drug discovery. I know that Merck has released a drug that was fully synthesized by a LLM, and that's going to be in the market. It's going through trials as we speak. It was not like some doctor who did years of research. It came into being in the last 2-3 years. They had trained a LLM specifically for drug discovery, and it has created a protein that can solve a specific disease. So that's being possible, and there are many other companies that are doing this. They are leveraging LLMs. They're training it on specific conditions and trying to figure out what protein can help us solve specific problems. And you'll see more of this. Drug discovery will become more accelerated. The knowledge will become a lot more dense. Instead of like some institutions having that intelligence, it's going to get more democratized eventually. Right? So that's happening. So more personalized medicine, faster drug discovery, drug manufacturing, all that is possible because of GenAI today. All right, this is on patient care. And this is actually a case study, and this is something that we started off with a couple of years ago, when we started to know that LLMs have become very good at understanding language. The first few problems that we tackled was clinical documentation. Right? Clinical documentation, as most of you know, or if you don't know, it's messy. When a doctor writes notes or even records them, it's not consistent. Like what one doctor might, some doctors might write very large descriptions. Some doctors may just write few sentences just to go through that administrative process, right? So there was a lot of variability. Now what's happening is we have almost like a Alexa or like a device that listens to conversations between a doctor and patient. And the interesting thing about this is that it's not only understanding natural language, it's also identifying clinical terms. Like if the doctor is saying something very specific to a drug, it is able to identify that, okay, that conversation is about a drug, or if it's about a disease or some medical term, it's able to identify that, okay, this is the conversation that's happening, this is the term that got called. So all that record keeping is happening in a automated manner. Now that simple exercise of just turning speech into documentation, it unlocks a lot of administrative cost savings. Traditionally, what would happen is once a doctor has had a conversation, he may have to go and record that conversation, not just in the the letter or the receipt that he writes to you, but also if they work in a large hospital system, they have to record the conversation that they've had, what did they diagnose. Especially in Western world, this is a practice. I'm sure even in large hospitals in India, that's also a practice. So you have to do that same administrative task multiple times, just to go through that administrative process. It's also by regulation in some countries that you're required to do that. Just that simple exercise of having an AI in that patient doctor discussion, it kind of eases a lot of the administrative work. That same system can be connected to other clinical documentation systems, and it'll update the records for you, and you just have to review and approve it. Right. So that's what's happening here. And in the early days, what we see is there were at least 2 to 3 hours of daily that is spent on just note keeping for patients. And this manual documentation, there were lots of errors, delays, people not knowing what has happened in the past interactions, a range of problems, right? Now we see that same 2 hours, it's saved per physician, but the impact at a hospital level is much higher. We are seeing about 3x, 4x levels of cost saving just because of one doctor saving 2 hours of time. For a healthcare ecosystem, this simple tool that we have created with GenAI is able to save much more because of compounding and other efficiencies it is bringing at scale. Yeah, and the cool thing about this is doctors feel less stressed. It allows them to focus on what they're actually trained to focus on, which is giving patients the focus instead of putting a lot of the time on administrative activities. So that's being unlocked here. I'll talk a little bit more about this later and how this is one of the key areas where GenAI is impacting healthcare. But this is one of the first things that people started to explore. There are companies, there are solutions dedicated just for this. Yeah, so this is the first patient care related GenAI solutions we are seeing. It may sound simple, but it's actually from a AI and engineering standpoint, it is extremely complex. Training a model on clinical data, making sure that it is correct, testing it in the market, consistently being able to write notes as effectively as what a reasonable doctor would do. That was something that was not easy, at least not until 2023, but now it's standard practice almost. I think you will see more of this in many places. If it's not being used, eventually it'll be used. In the real world, I think there are some companies that are already doing this. Microsoft has DAX. It's a software that you can purchase and plug into your systems to do this exact clinical documentation work. And there are many others, right? Like GPT has collaborations with Epic. They can assist with patient messaging and work with your EHR systems for documentation. So you will see more of this happening across different healthcare ecosystems. All right. The next one, now shifting from the clinical setting, I want to move towards the insurance space. Insurance, again, healthcare insurance. There's a specific activity called prior authorization. So when you buy healthcare, not just in this country, but anywhere, there are certain conditions for which you have prior authorization, which is you don't have to like go through a large claim processing activity where you have to prove that you have been diagnosed with something. If that condition is pre-approved, you can get your claim almost instantly. But instantly is not really a operational term. There's nothing instant in the insurance world. They still take time to process those claims. In the past, it used to take about 10 days on average to do prior authorization. So if you get diagnosed today and you submit that claim, it takes about 10 days for you to get paid for that claim. Now what's happening is we have AI that is reading your claims, and it can immediately detect that, okay, this person has the right product. This seems like a legit claim. And the doctor or the clinical treatment that you're going through matches what that authorized claim is allowed for, right? All that gets checked instantly by an AI, and you can get that prior authorized claim processed almost the same day, if not instantly. So that is something that is happening because of AI today. There's a lot of automation in this space. Now, even with this automation, right, there are some challenges. I'll talk about them later, specifically on fraud, because things are becoming easier to document, easier to process. People being very creative, they are able to use this automation as a leverage to do bad things, right? They can be fraudulent claims because of this AI assisted processing. So that's something that's happening. While it's making things easier, but it's also making things easier for criminal activity as well. But the benefits are clear that you can use AI to improve operations or operational processes. But it's still early days on how to govern these systems correctly. Okay, but this is already happening. Most insurance companies have some AI assisting them. If there isn't a person, and there's at least an AI studying it and giving you a status on, okay, your claim is in this stage, it's being processed by XYZ person. That level of automation is increasingly becoming more accessible because of AI today, and AI specifically because it's looking at unstructured data, right? When you do claims processing, you are submitting bills of a particular hospital. That bill may not look standard, right? Different hospital will submit different kinds of bills. They might be handwritten notes. They might be clinical documents. All of that is messy, and that mess is what is now being interpreted easily with GenAI solutions. So that's the unlock that has happened in the past few years. Okay, so this is another zone where GenAI is helping, improving operational costs or savings and increasing speed to response. The third place where AI is helping is in fraud detection. For those who don't know, apart from the financial world, fraud happens a lot in healthcare as well, and it costs billions of dollars. And this is not just for insurance companies. This is also for hospitals, pharmacies. There are many actors who get affected because of these fraudulent actions by some people. What it does is it basically increases costs for people who are actually behaving correctly. So if let's say a health insurance company gets hit with a large fraudulent activity, that cost ends up getting passed on to the customer eventually. So a lot of time, a lot of effort is actually being put into detecting and making sure that all claims are compliant by regulation, right? And in that space again, we are seeing AI stepping in. Earlier, we used to look at just structured data for detecting fraudulent transactions or fraudulent actions by different actors. Now we are not only looking at structured data. When I say structured, it's bills, transactions, anywhere where there's a numerical entity. Now we are looking at medical images, records of what volume of drug has been prescribed. There are LLMs with clinical knowledge that know that, okay, if you are diagnosing a person with this, this is generally the prescription that most practitioners give. And if there's a deviation in that prescription, the LLM is able to quickly catch that. Those kinds of multi-dimensional perspective of looking at fraudulent claim is now possible because of GenAI. Now, what it eventually does is it reduces false positive and it increases early detection of problems. And that itself saves millions of dollars. I know at least in 2018, 2019, when some of these AI techniques started to be used, something as simple as drug administration, right? There could be places where, actually there are places where doctors or even providers, hospitals, they may claim that they have prescribed, let's say 100 ml of a particular drug, but really depending on the volume of patients and the amount of drug that is required for different conditions, right, maybe far less. That deviation itself, detecting it was very complex for traditional systems, but with GenAI, it's able to catch those very quickly. And we're able to like block those bills or at least call out, hey, you need to review this. I think you are over prescribing a certain medication. That kind of feedback, instead of having a person reviewing it, you can have an AI give that feedback for further analysis, right? So that's happening in the fraud detection and compliance space. And it can touch anything, right? It could touch anything from medical image analysis, document review, billing behavior. This is a big one where fraud can actually happen. And even audit trails, it can like identify patterns. Usually bad actors have certain bad patterns, right? They will keep doing the same mistakes over and over again. It could be unintentional or it could be intentional, right? Identifying whether it's intentional or unintentional is extremely complex. But at least being able to detect that there is a pattern in your behavior is something that AI models are extremely good at, even better than humans actually. You could have like a mixture of experts reviewing claims. They might miss it. In fact, professional criminals are very good at getting some of these claims processed, but AI will catch that very quickly. So that's happening in the fraud detection and compliance phase. We're already seeing millions of dollars being saved. On an aggregate, it should save billions, if not multi-million dollars for different organizations. So that's another space in patient care where we are seeing GenAI benefit. Okay, I'll pause here before I head into the next session. Let's see if there are any questions. Okay. I'll give it another 20 seconds. Feel free to pop your questions on the chat box. I'll just read them through there and see if I can answer them. Okay. If there's nothing, I'll move on to the next one. So far, I've been focusing on specific zones, right? Like clinical zone, the health insurance zone, finance and fraud related activities. A big area of healthcare is at a policy level, which is usually unseen, but it makes a lot of impact on almost everyday life of our general population, right? So there are specific entities across governments, right? Every health ministry has a population health department, which is not only looking at the subjective aspects, like the policy level aspects, but it's also looking at dedicated data across zones, like how is the population increasing, what is the kind of demography that I have that I need to manage, do I have enough drugs for a potential outbreak. All this is done at population health level, and there are dedicated departments that do it. And GenAI is impacting this area a lot, right? Traditionally, this is something that again was limited by access to data, access to resources, and even experts. You needed specialized experts to analyze that data. Now that limitation doesn't exist because it's almost now LLMs have made these things more accessible, right? Analyzing data, synthesizing different insights. That's becoming more democratized because of LLMs. The third area that it is unlocking is simulation. I'll talk about it in a little more detail. I have a few examples. So population health intelligence is one more area where healthcare is being impacted because of AI. The first one, again, this is synthetic medical data. Traditionally, again, I think I've talked about this, right? Privacy laws in different countries, it limits research. Again, rare diseases have limited real patient data. Because it is real, you only have very small samples, right? It takes years, if not decades, to find patients with that specific attribute to study, right? So analyzing data is extremely difficult. The third one is, even if you have that data, how will that analysis apply across a diverse population is difficult to simulate. And one of the things that we are increasingly leveraging is synthetic medical data. So even if you have a small sample, if you have AI models that are trained on general medical knowledge, that AI model can look at these small data sets, like small rare disease samples, and create, I won't call it perfect, but at least good enough samples of synthetic data that can be used to simulate different conditions. Right? So you can create these synthetic data solutions. What this does is it kind of unlocks some of these limitations that we see here, right? Because of that synthetic nature, you can easily share that data. You can share that with across countries, across organizations, departments. So that limitation fully gets unlocked. It can also, because GenAI is able to study small data and create more synthetic examples, you can literally use that generation capability to simulate trajectories. So let's say if you have a rare condition that focuses only on a specific demographic population, you can create synthetic samples that kind of replicates across demographies, across regions, across ethnicities, lifestyle parameters. You can create those synthetic images and then study, okay, how is this disease going to evolve, or potentially can exist in other patient populations that can be studied using synthetic samples. So it almost helps you simulate different scenarios. I think the last one is again related to privacy restrictions. It almost gives you access to unlimited data sets. You don't have to worry about limited real patient because of these synthetic data solutions. So this is another area. And the synthetic medical data is important even from a policy standpoint, because once you're able to simulate, right, and you're able to figure out different patient trajectories across the population, you're able to make some decisions at policy level. Like, do I need more hospitals? Is this like a COVID-like situation? Do we have enough experts? Will I need more experts 10 years down the line, 15 years down the line? Do I have the institutions to train these medical practitioners? All those policy level decisions can be made because now you can simulate with synthetic medical data. So that's one way synthetic data is helping healthcare at a population level. I see a few messages come through. Yeah. Okay. Okay. Now, the other place is predictive analytics. Now, predictive analytics is not new. Okay. Predictive analytics has been there for decades now. Earlier, we used to work with what we used to be called small data, like data that can basically live on a spreadsheet. And in that, we would analyze and do simple forecasting or predicting what would happen in the next few days at best. Now, at least in the early 2010s, there was a movement to digitize a lot of the data. And at that point, I'm sure most of you must have heard about the term big data, right? We used to have large enough data sets which are structured, which are still structured data. And on top of that, we used to apply what we would call as statistical or machine learning techniques to do predictive analytics. Now, what are predictive analytics? Now, imagine you're an insurance company and you want to reduce the chronic patients, the burden of or the risks of chronic diseases in the members that you have that have subscribed to your products, right? Now you can't go and tell everybody, hey, I think you are one, you need to first know that a person is at risk of diabetes, right? Before they actually become diabetic. So doing that was practically difficult unless you have some magical healing abilities or an extremely good doctor who can predict that you may be at risk of diabetes. What companies started to do is they started looking at this big data and started building predictive models. So we would use that data and see if I can predict if somebody is going to be diabetic in the next 3 months. And this is based on purely past behavior, because you've seen other patients who have similar behavioral patterns, clinical patterns, eventually becoming diabetic, right? This analysis of structured data to actually being able to predict that there are risks associated with patients. This is called predictive analytics. Earlier, it used to be very reactive. You would just look at data and then you would treat them. And at that point, it was pretty late, right? You already know that person is diagnosed with diabetes, and then you react on it. Eventually, predictive analytics became more important. We started to preempt if a person is at risk. Then what is happening now is we are not only predicting, but we are also proactively identifying. Okay, in my patient population, here's the top 10 people who potentially are at risk. And then it's not just insurance company, it's also care providers who get this intelligence and they're able to respond to that patient. Like if we know that somebody is at risk of chronic diseases, the treatment that we advise them gets tuned based on the intelligence that is provided. And this has been happening in the 2010s. Insurance company would build these models. They will share it with the network, like where you are likely to visit. And the doctor or the provider there would, when I say provider, it's basically a hospital or a doctor. They would have this intelligence and they would say, okay, I think we need to tune your treatment based on this intelligence. That's something that was already happening. Now with AI, what is happening is that same predictive analytics capability is more enhanced. It's becoming more accurate. We not only have structured data, we also have unstructured data that is providing more intelligence, more accurate information. So earlier, maybe I could predict somebody who would be diabetic in 6 months. Now, because we have more data, more high quality insights from AI, we are able to reduce that window to 2 to 3 months. Within 3 months, I can tell you, you may be at risk. So that's the quality of improvement that we are seeing, not just from a data perspective, but also from a technique perspective. Okay. A good example of this is in ER visits. A common challenge in most modern developed countries is there are limited number of doctors or providers and limited facilities. So a lot of times when you're struggling, right, when you're in pain, you do want somebody to treat you, and most of those visits end up being in emergency rooms, even if it's for something as simple. And it's a known human behavior. Let's say if you're a parent and you have a very young child, if you see that child struggling, you you are compelled to do something, right? And most of these visits tend to be from young parents, these ER visits. What While this sounds benign for a patient, but from a healthcare standpoint, it's extremely expensive. If you're treating somebody for something very small, you are locking resources, right? You're locking the few resources that you have for a specific patient. In that meantime, there might be somebody with something more serious who probably needs a emergency room facility, but is blocked because it's already used. That was a constraint we used to see in ER, but with predictive models, we were able to reduce it by 25%. And 25% is a lot of money. It's millions of dollars every quarter for one hospital. So imagine that being used across hospital. So there are billions of dollars worth of savings there. And we already know. I mean, I've spoken about a few predictive solutions, right? Prediction of risk for diabetes. It could be hypertension. It could be cardiac problems. It could be many. Like you can look at many such clinical conditions and build models on that specific clinical condition. And each of those, if you're able to do it effectively, can give you a return of 3x. Like if you invest $1 million, you'll probably be saving $3 million at least if you release it to the market, right? So that's the power of predictive analytics. We've seen it being effective during 2010s. Now it's becoming more accurate. It's able to look at a wider range of problems, more complex problems. That's what's happening today. Okay. Okay, I will move on to the next one, which is health campaigns. Now, health campaigns is kind of slightly out of the clinical world. When I say health campaigns, think of polio campaigns, right? We know that it's a big problem. It's a major thing that we should take seriously. So there are many campaigns that run across the country, across different regions, right? Traditionally, the way it would work is you would have very small, underfunded teams that would go out there. They'll knock on door to door. If they still do actually. They go knock on door to door, figure out if there are children, then give them polio drops. They would actually inform you that we are running a campaign, and as part of that campaign, there are free polio drops that you get. It was a very human and manual way of doing it, right? And again, these departments tend to be extremely underfunded, and it's not just an India problem. It's a problem across the world. What's happened now is with GenAI, you are able to run these campaigns or even create these campaigns at a much lower cost, and you're also able to capture dynamics for which you would have needed experts traditionally. So if you wanted to do a campaign in Tamil Nadu versus something in, let's say, Haryana, the kind of campaigns you might run would look very different. Today, I think it's a blanket approach, but customizing campaigns again takes cost, right? Now with GenAI, you are able to create these campaigns almost instantly. You can give it some parameters saying, here's my cultural background, here's the demography, here's the behavioral factors, and you can create a customized health campaign for different regions. You can even personalize those messages. You can like create a campaign focused on city dwellers or middle class people or rural people who may be a little hesitant in taking medical advice, broad medical advice. Right? So that level of optimization, tuning of campaigns is becoming more accessible, more approachable to public health campaign specialists. even with underfunded resources, you could use AI today to create more scenario-specific campaigns. So that's another area where GenAI is benefiting the population. I'll pause here again. Let me see if there are more questions. Feel free to ask me questions. I can like spend 2-3 minutes and talk about what I'm seeing from my practice. If there's something that you are trying to explore and are not sure of, I can maybe even direct you in terms of what you could think about, right? So feel free to use this time for that. Okay, if there's nothing, I will move on to the next one. So far, I've given you examples, case studies of what is working with from a GenAI perspective. Now, what I want to do is I want to actually talk about what is actually working and what is not. You will see a lot of hype, right? Hey, AI can solve everything. There is potential to, but there are limitations as well. I will talk about those. Okay. The first thing that is working is time savings. You know, the clinical assistant that we spoke about, which is sitting in a doctor's room capturing notes. That small thing is extremely effective, and it has been proven to save a lot of time and even physician satisfaction, right? They are surprised by how effective it is in their day-to-day work. So that's something that's working extremely well. That example alone is creating a lot of enthusiasm for AI. It's kind of opening up. Okay, earlier doctors used to be extremely hesitant in believing anything AI or machine learning related. In fact, I have gone through some extremely tough conversations in the past decade. So you have clinicians who have gone through decades of training to be able to diagnose a condition, right? And then me, who is probably just graduated, built a model in 2-3 months and saying that I can do this job as good as somebody trained for decades, was a very difficult sell, at least a decade ago. Slowly that is changing. Now even doctors appreciate that machines can do their job effectively. They can use it in different ways. It's not necessarily replacing them, but it's at least helping them save time, making things faster, improving the quality of care that they give to patients. That they are realizing. But a decade ago, this was not easy, at least for people like us trying to challenge existing practices. So these are some things that are working. It's also helping us show that AI can solve real world problems. The second zone is diagnostic robotics. In most places, you will see that there are tablets or some specialized device that is capturing your details. That alone, it's not a traditional tablet. It has been trained on clinical data. It is capturing a lot of intelligence about you already, and it's also transmitting real-time recommendations. These devices are also helping reduce costs. We have seen it reduce the emergency department visits by 25%. So if a patient walks into an emergency room, you can have this device look at, it can ask a bunch of questions, adapt to that questions, other responses, and figure out whether this person needs a ER visit or something else. That is done through AI today, and that alone is saving about 2.9x return in investment rate. So that's another place where AI is helping in healthcare. The third one is in personalized treatments. This is not fully out there in the market, but the potential of being available to mass market is increasingly becoming useful, and it's probably going to come very soon. I think we just need to figure out the policy level aspects of how to do this effectively. So the 100,000 genomic data plus personalized treatment is something that we are able to bring because of AI. So these are three big areas where AI is helping. The other places are in prior auth, right? Same day processing of claims. I don't have it in the top three because this is also a problem, which I'll talk about in the next section. Again, it's helping increase. There are some studies that say if you use AI effectively, 40% of healthcare working hours can be reduced. And we're already seeing $200 billion of saving in US specifically because of mix of things, not just AI. It could be AI, machine learning, traditional analytics. So it's a mix of things that we are seeing here. Benefits of mix of things, and the key part of it is also AI. So lots of savings, benefits that are being passed because of advances, not just in technology, but also in infrastructure. Okay. So that is what is working. Now, what is not working? The first one is hallucination problem. Most models now that you see, the best-in-class models now, they have reduced hallucination by quite a bit. But the problem of hallucination still exists. And identifying that is not an easy problem, especially in the healthcare world, right? If a machine learning model or a LLM hallucinates, the impact is extreme. It can even be life and death in many situations, right? So that problem still exists. The second is in bias in training data, right? One thing that we know from practice is depending on your school of thought, right? The way Europe manages healthcare versus how US manages healthcare versus how a China or a Japan manages healthcare is very different. And depending on what kind of data you have the model trained on, the recommendations, the analysis will have a bias. And it might be biased towards the US or the Western or whatever it is trained on, right? So those biases, removing those biases and bringing a more generalized or a focused, unbiased recommendation is still a problem. And it's improving, but that problem still exists. The third one is around privacy and security risks. And it's not an AI problem alone, this privacy problem. It's also a digitization problem. Because now that more and more data is getting accessible, it's being transmitted digitally, there's a lot of privacy risks. So a lot of highly sensitive data, if there's a hack or some sort of a breach, that data can get exposed very quickly, right? And these have happened in the past, and that risks will continue to be there. There are many, let's say, policy and tools that are available to reduce it, but that risks I don't think is going away. The other part of security risks is because we have AI solving problems, that same AI is also being exploited to create other problems. And we start seeing this in car insurance. About 7-8 years ago, many companies started to reimburse for your, let's say if you got into an accident, instead of you having to get a an insurance person to come and review that damage, you could take a picture and send it to your insurer, and an AI will decide whether this can be claimed or not, and what amount can be claimed based on just the pictures alone. Right? Today, what is happening is people are creating synthetic accident images and submitting it, and AI itself is not good at figuring whether it's a real image or not. And those claims are being processed. I think now most companies have stopped this practice. It still goes through human reviews. So those kinds of exploitations are happening because of AI solutions. And that leads me to the last one, which is the human in the loop imperative. In healthcare specifically, most people agree that AI cannot diagnose directly. It has to go through a human specialist, right? And the reasoning is a little complex, right? For example, if you look at this image, right, if a doctor is using a device and the device is giving a recommendation based on that conversation, and it's not correct, then who do you hold accountable? Do you hold the doctor accountable? Do you hold the manufacturer of the device accountable, or the AI engineer who developed the algorithm accountable? Right? There's no easy answer to that, but the consensus is the diagnosis should come from the doctor, and we should not fully rely on AI machines, at least not until the next few years, until we figure out the other problems fully. So that's what is not working. There are problems. It's not bulletproof. We have to think about these things when we are building these healthcare solutions. Okay. I'll quickly check if there are questions. Okay, I see some comments. How to predict epilepsy? I don't have a good answer to it. It might need a combination of hardware, software. I'm sure if I do a few Google search, there might be solutions already. And the reason why I'm able to say that is Elon Musk has created implants. So people who are, let's say, who are not able to use their muscles to communicate, they're able to have a chip embedded, and that chip is able to learn brain patterns, and it's able to interpret those brain patterns and interact with a digital device like an external audio device or even a computer, right? Instead of you having to type or vocalize it, the chip itself will interpret how the brain is the brain waves are moving, and it'll synthesize it and it'll create an action. Today, the implementation is very crude. It can do something like move a mouse based on thought alone, or type a message, or move your wheelchair if you are fully disabled. Things like that are possible today. So that same technology should be able to detect epilepsy as well. So there are lots of wearable devices that are coming out there, and that's what I want to talk next, right? What does the future hold for us? There are three big areas which I'm actually excited about. The first one is VR. VR is already real today, right? VR with GenAI. Medical training today tends to happen with real live interaction, right? You have to wait for cadavers or real patients to train real doctors, right? Today we have companies that give you headsets, and it can do simulations. It can generate a patient that has a specific condition, and you are interacting with that patient live. So medical training through simulations is possible today. So and this is only going to become more and more advanced. Today we can do something like understanding specific disease conditions using VR. In the future, we can also do something like understanding anatomy, right? You can go through the human body and see different interactions that are happening at a molecular level as well. So that level of VR simulations are being created with GenAI today. The second one is wearables. Today, Apple Watch, right? It has a lot of powerful predictive tools already embedded there. That is only going to become more and more advanced. Right? From watches to something more complex. An interesting one I can talk about is fall risk. In most developed countries, senior people tend to live alone, and that's a pattern there. And when they're living alone and they fall, the risks are huge. It can even mean death, right? Because they can't reach the phone or ask for help. it's very difficult for them to recover from that fall. So just that simple ability to detect that a person has fallen and needs help is something that AI models can do extremely well. You don't even need a GenAI model. You can use traditional models as well. And those kinds of devices are becoming more and more accessible now. It's also becoming more and more affordable. And you will see more of these coming out in the market for different medical situations. Even epilepsy, I'm pretty sure somebody must be working on a wearable to predict and even alert if a person is getting an epileptic seizure. So this is possible today, or increasingly becoming part of the future, right? And the last one is robotics. Robotics may take a while. I think the foundational technology is there, but there's not enough data. Okay, what I mean by that is, you and I, from the time that we have been born, right, we interact with the 3D world, and we have lots of senses, right? We have touch, feel, sight, audio. In robotics, you need that same level of sensory capability, right? Understanding intelligence from multiple sensors and responding to the real world. That is a difficult challenge for not just from an engineering standpoint, but also from an AI standpoint, right? Even Tesla, right? People who claim that there are self-driving cars, they're not fully self-driving. You still need a human if there is a crisis, right? So that will take some time, but eventually this will come to surgery, care robots. Care robots are becoming more real, but the range of features that they have is limited. And this is something which I expect in the next 5 years to become more real. In terms of solutions, right, there are already digital health avatars. So instead of you having to talk to a real doctor, you can talk to a virtual doctor who can listen in and maybe give you some early indications of what you could do. If it's a simple cough, it can recommend simple solutions. These things are already there in the market if you're not aware, right? And the second one is in clinical decision support. It can analyze patient data. Most doctors tend to use this. Most advanced facilities will have this to some extent. The AI there will give some early recommendation to the specialist, and the specialist will decide, okay, if it makes sense to choose that recommendation or think of some other solution. So these things are already there. And the last one is the more exciting one for me, at least. Medicine or anything in science, there are specialized zones, right? Like if you are a cardiology expert, you only get trained on, you may have foundation of other things, but you may be an expert of cardiology, right? The learnings from cardiology may not be directly available to, let's say, somebody who is focused on, let's say, eyesight, right? But there might be interesting insights that are interconnected that both of these specialists might care about, right? Those interactions are difficult to identify if you just have individual people, looking at their own careers. But with AI, the AI is able to learn what the cardiologist is doing, what the eye care specialist is doing, and come up with connections, these interesting new insights. And think about this at a mass scale, right? That insights alone can help find new ways of treating patients, or even connections that we haven't figured out yet can be identified through this automated research. You can basically train LLMs to come up with these interesting insights based on different things you observe. That is happening today. It's very prompt driven, but eventually the hope is medicine can have like an LLM that is exploring these new areas with all the medical knowledge that we have collected so far. So that's the third most interesting thing. I think from my session, this is what I had. I can maybe park some of the time for any questions you folks have. I'll stop sharing screen and we can have a live interaction if required.
Sure. In case if there are any questions, this is the time to ask. You can put the questions in chat or question box.
Thank you. Predicted. Okay. Predicting epilepsy again. Like I said, I think maybe a very high level answer is first you need to identify patterns. Right. You need to have the data that is capturing those patterns. It could be brain waves, nerve patterns, and then collecting the data across different patients, and then building a model on top of that data, right? And then the second thing that you would do is see if it's consistently able to predict if a seizure is going to happen. I am pretty sure that this has been done to some extent, but whether it is effective through AI models, that I think I may need to study a bit. But the technology exists. Like we are seeing some of these capabilities already in other spaces where patients with severe conditions or diseases are able to use implants that are capturing data and transmitting to an AI entity or a computer, and using that to either alert systems or even interact with the real world. So those things are already happening. Epilepsy is a very specific medical zone which I haven't fully studied, but the technology is already there. It's just a matter of bringing that technology together and putting it into the real world.
I think we are done with the questions then. So let me take this moment to thank you, Akbar, for taking this session. And as always, very insightful, and I'm sure the faculty members learned a lot. And there is one more question in case if you want to take it. What are the electronic wearables?
I don't have like a specific name, but I can tell you about what Elon is doing, right? I'll just paste his link there, right? It's called Neuralink, if anybody has heard about it. This exact technology can be used for specific, brainwave related conditions, right? That is one. I'm sure there are competing, but Neuralink is the most popular one that I'm familiar with.
Thank you. Venuji is saying thank you.
No problem.
Thank you so much, Akbar, for taking the session, and we hope to bring you back for the next cohort, which is starting on December 1st.
Okay.
Yeah, next week is there's a break, and then the next one is December 1st to 6th. So I'll check with you regarding your availability.
Sounds good. Thanks.
Thank you so much. Thank you.
Okay,
Thank you,
bye.
everyone. Thank you for joining. Please join tomorrow at 6 o'clock again. Thank you.